Hey everybody, welcome back to Crow's Java Programming Tutorial Series. This is lesson 4. We're going to be talking about modulo, sometimes called modulus, constants, and conversions. Hope you guys are excited to get going. The previous lesson's homework asked for you to take current population, and it gave you the current population at that time. It showed that there was one birth every 7 seconds, one death every 13 seconds, and one immigrant every 45 seconds for an entire year. And so I was hoping, you always could do it by system.out.println and just do the math every single time. There's a variety of ways that you can create this equation to help benefit you and program this in a variety of ways. So the way I chose to do it was I'd take my current population and I found births per year, deaths per year, and immigrants per year. So if there is one birth every 7 seconds, we can extrapolate that to minutes by doing every 60 seconds, you divide that by 7, so there's about 8.5 births per minute, and then 60 divided by 13 will give you deaths per minute, and 60 divided by 45 will give you immigrants per minute. You could do 60 divided by 45, and then times by 60 to get per hour, and this is to get per day, and this is per year. Okay, and so I have set these variables equal to this equation to help make the equation a little simpler, a little easier to read, make a little bit more sense in my opinion. You might be wondering what the int is in parentheses there. If I haven't mentioned it before, it is called casting. It's how you change an equation into a certain data type. Here we're changing them all, making sure they're all integer values at the end. So they will still be decimals when they're multiplying through, but then they will convert to an integer to get births per year. So how many years in the future do you want to see the population? And I have created an input so this equation can morph into something that the user can interact with. So I could put 5 years, which is what the equation asked for, or I could put 100 years, and then it would give you a completely new, so apparently in 100 years, the U.S. population would go up by about 260 million. And so you can see that gives a different dynamic to the problem and is more relevant to what we did in the last lesson. The total population is another variable that I created that did the current population plus years times births per year plus immigrants per year. So it combined those two. And then multiplied it by years, and then we subtracted years times deaths per year. And since the order of operations has these equations happening first, it would add to it would add to births per year and immigrants per year, and when it multiplies by years, so it would add this, and then it would subtract this. And then I would print out my total new pop. And so you notice each one of my variables are very clearly and intentionally named so that anybody could come in and read my code and see what I'm talking about in this equation. If you have any more questions on that problem, please feel free to leave comments at the bottom of the page. So now I'd like to do a compute area equation. And once I have this compute area class set up, let's talk about constant. A constant is named and cannot be changed. So just like you would think, a variable is something that can change. A constant is something that stays the same. Keyword final needs to be used in order to describe it as a constant. If we did final double pi equals 3.14159, that would create a variable pi, a constant pi of the double type, and it can never be changed. So instead of having to type out 3.14159 and memorize it, or say if you were to make pi more exact, you wouldn't want to have to write that out every time or have the chance that it could be changed. So you want it to be a constant. And so constants are always fully capitalized. If you have two different words that you need to put into a constant, you need to use an underscore to separate them, but they are all capitalized. Every letter in it is capitalized. That is pi. And to compute area, we are going to do pi times radius squared. And so we are going to need to import a new scanner. So we're going to need to do scanner input equals new scanner system.in. To get the input of the scanner, we need to name it, and it needs to be imported. Control-Shift-O will automatically import your java.util.scanner. Now we can prompt the user by doing sysout, control space, what is the radius of the circle? We need to say double radius. This can change. We don't know what it is. We're going to wait for the input. Input, so we're accessing the scanner class, which has the ability to use input and call on the next double. So the next double entered will become radius. And so we can find double area. Area equals radius squared times radius times pi. Okay, and then we can do sysout. Say the area of a circle with radius plus radius. This will give us our radius, and then we need to have a plus sign on each side to separate the double variable from a string. We're pretty much turning this into a string to be printed by doing the plus. So is space area. Now we can test it. 1, it's an easy test, be 3.14159. Perfect. Okay, so now you've just computed area. Now we're going to create a new class. And I'm going to teach you guys the basics of understanding a modulo. So a modulo is the percent sign. So here are all the numeric operators. We've used plus, subtraction, multiplication, and division. And this percent is what we call the modulo. It gets the remainder of whatever two numbers are being divided by each other. So 20 divided by 3 would get you 6, with the remainder of 2 left over. Okay, to practice using the modulo, I'm going to ask you guys to complete this problem. Feel free to stop and try to do it on your own. But it is quite a difficult problem for where we're at, and it is part of a teaching moment, so you're welcome to just follow along with me. But this is write a program that reads an integer between 0 and 1000 and adds all the digits in the integer. For example, if an integer is 932, you sum all the digits, the 9, the 3, and the 2, to get the answer 14. So 9 plus 3 is 12, plus 2 is 14. So that's what we're doing. We're trying to get each one of these and adding them together separately. Okay, so we're going to need to use the modulo operator to extract each digit and use the divisor operator to remove the extracted digit. So 932 modulo 10 would be 2, because 932 divided by 10 would go into 932 93 times evenly if it was 930. And then that leftover 2 is the remainder, what does not go into that 930. But with a divisor, 932 divided by 10 truncates this 2, so it pretty much removes it from what we're thinking. And I'm going to show you guys how we're going to do that right here. So first and foremost, we know we're going to be entering a number. So we're going to put in a scanner from the very beginning, and we're going to do new scanner. Okay, and once we have it, we can do Control-Shift-O, make sure that we have a scanner imported. And we're going to need to have a variable stored for our number, int num, and since there's only one number getting entered, it's pretty simple, and you can just put int num. But we do need to prompt the user to say sysout, enter a 3-digit number, actually any 3-digit number. Okay, so now let's stop and think about what we have so far. So we have a 3-digit number that someone is adding in, and we are saving it as num. Now this number needs to be broken down, and in each individual digit needs to be added together. So we're going to need to use the modulo, that modulo 10, to access the digit in the ones place. Then we're going to have to truncate that ones place digit. Once we truncate that ones place digit, that tens place becomes the ones place digit, and we do it over again. And I'll explain as I go along here. So think about how you could do that yourself. So int first dig equals num modulo 10. And in the problem, it gives you that hint. The number that gets inputted, modulo 10, to get that 2. Okay? So the first digit is simply num modulo 10. And then we're going to need to do int second digit equals num divided by 10 first to truncate to get that 93, and then modulo 10 to that. And then int third dig equals num divided by 100. Actually, it doesn't need parentheses at all. Because if it's 932 and you're dividing by 100, that gets how many hundreds are in that 932, and there's 9 of them. And then it truncates the last 2 digits. So if you did int sum of digits equals first dig plus second dig plus third dig, and we ran it, we printed it, this out, sum of digits, we ran it, and we did 932, like they tested it, it would be 14. If we did 999, it'd be 27. Okay, so that's a very simple and straightforward way in order to do the modulo. Okay, we're going to do a little bit more practice with modulo on a later lesson, but right here I want you guys to, as homework, to do a cost of driving activity. So you're going to write a program that prompts the user to enter the distance to drive, so how far the trip is that they want to drive, the fuel efficiency of the car in miles per gallon, and the price per gallon, and then it needs to display the cost of the trip. In order to figure this problem out, first you're going to need to know to put in inputs. It looks like there are 3 right here in driving distance, miles per gallon, and price per gallon. And so you're going to need to make those variables. Then you're going to need to take those variables and do a mathematics equation and use some logic to figure out how, when you enter these in, it will convert into the cost of driving a certain distance. Thanks for watching, guys. Hope you enjoyed the video. If you felt like it was beneficial to you, I'd really appreciate a like or subscribe at the bottom of the page. Hopefully I'll see you next time on Crow's programming course. That was lesson 4, signing off.